Is it recording?
Take videos, yeah.
Okay. I think we're good. Okay. So now we're gonna do still the Bluman 9th edition. This time it's gonna be number 42. Okay, so number 42. Now it's the opposite. That here, instead of us having to calculate the area between either two bounds or anything, we're actually gonna, wait, let's just stick to the color, it doesn't matter. We're actually just gonna, we have the area and we're gonna calculate the z-score for it. So we know if we have this area, and then in the middle, I'm gonna have my 0. And my z, they said is somewhere around here. Here's my, this is my z. We don't know what it is, but we know that this portion right here is 0.4066. Now, I can do multiple ways of solving this. I can either, I know we can use a calculator, obviously, or we can just still use the z-score table, but now instead of using it from the outside and going in to find a probability, we're gonna do the opposite of that, where we have the probability, so we're already inside the table, and then we're gonna go outside. It'll make sense in a second, but for now, let's just think about that. We know what the z-score is. I've said that like 2 times already. Z-score is just how many standard deviations away from the mean you are. And here I am just a random number. Oh, this is not a pen. I'm just a random number z away. And I started at 0. So again, this blue portion is going to be that bigger purple area if I take away that smaller pink area. Because if I do purple minus the pink, if I do like the bigger purple area right here, minus the smaller pink area, I'm gonna end up with all of this like here being the blue, which is like that blue right here. Okay, so now what I can do is I already know the blue area, right? If you guys remember from here, we always would do the bigger area minus the smaller area. Here it's no different. We just don't know the bigger, because we don't know z, we're not gonna know the bigger area. However, let's just call the bigger area, I don't know, x, okay, because we don't know it. So let's call this big purple area x. But I know that if I have x and I take away minus the probability that my z is less than 0, I'm gonna end up with the area in between, which is the 0.4066. So I can solve for x by just isolating it. I can add the probability of z less than 0 here so that they cancel out, but I have to also add it to this side, plus probability that my z is less than 0. Okay, so this is what my x is, my big X. Because basically I just need to find the bigger purple area so that I can find what my z value is. Okay, and again, we've talked about like how you can subtract them to find the area in between. So obviously the area in between plus the area to the side, which is the pink portion, which we took away from it, would give us the actual bigger area. So I need to look at the table to figure out what the probability that z is less than 0 is. Again, if I go to the table, I have 0 right here and 0 right here. So this is 0.000. It will give me 0.5. So my area here we already know is 0.5, which makes sense because if you are on the mean, the probability of you being less than or greater than that mean is gonna be just 50%. I mean, sorry, what am I doing? Why did I do 0.00? I mean, 0.50. Yeah, it makes sense. 50% is the chance of me being less than or greater than that value. Give me a second. Anyways, okay, so let's do that. It's gonna be 0.4066 plus the probability that I'm less than 0, so 0.500. And this is gonna give me 0.9066. Okay, so now I know what my x is. Again, the x was that bigger area under the curve, right? It's another way of saying the probability of z less than some number. Obviously, well, actually, we still don't know. Well, yeah, we don't know that number. What it is right now. Actually, that's what we're trying to find. So yeah, this big purple area we figured out is 0.9066. So now what we can do is we can go to our z-score table, which we were using the whole time. And instead of looking at the edges or on the outside, like we don't look here anymore. I don't know if you guys can see what I highlighted, but sorry. We're not looking here anymore. What is that? What is happening? Okay. Well, yeah, we're not. Wait a minute. Okay, we're not looking at here anymore or here. We're looking from the inside and going out. Okay, so how can let's see. So, okay, it's gonna be like honestly a little bit of a scavenger hunt, but we can see something. So we know that this is 0.9066. Yeah. So let's just go to the area where there's 0.9s. I mean, on the top it's 0.5, 0.7. We're not looking at that. We're looking at somewhere here around the bottom. And it's really close to the beginning of the 0.9s. So I can let's say my eye landed right around here. I can go, I'm like, okay, this is 0.932, closer, 49, even closer, 66. This is exactly what I'm looking for. So now I do the opposite, where I take that number and then I go to the outside. And I'm like, okay, so I have 1.3, so that's my first piece of the puzzle. And then my second piece is this 0.02. So I'm like, okay, that makes sense. So now I can just add them. So it's gonna be the 1.3 plus the 0.02 to give me 1.32, which is what my z-score is. So now I know that my z is just gonna equal to 1.32, which is what they were looking for all along. So yeah, that's my answer. So just a little recap, we have the area, we have the pink area because we can figure it out from the table, and they gave us the blue area, and we know that purple minus, or here, purple minus pink will give me blue. So if I wanted to solve for the purple, I can just do, so purple will just be blue plus pink. And then that's how we got our x right here. And then we went to the z-score table and figured out where my x was, and then went out to see what the z-score would be. So yeah, that was a small recap of what just happened. But now I'm gonna show you guys how to do a different way, which is the calculator way. And I don't know if your professors might want you to use it to check your work or something, but we can do this using our calculator. And the way we do it is we do something called an inverse norm. We're gonna go to the same place we were, but this time instead of choosing normal PDF or normal CDF, okay, just back in case nobody watched the previous videos, we went second and then bars. or the distribution button. And so the first option is normal PDF. We're not looking at that. We're not looking at a normal CDF either. However, we are looking at the inverse of the norm. So that's the third option. Now, a little small thing for this particular problem, or just, yeah, whenever they're asking you for like I mean, I guess it is for this particular problem, but we already are, we're gonna need to do the same exact math that we did. However, this is just gonna save us that scavenger hunt that was happening like a while ago. And now instead of like I just look at I still need my x. I still need to figure out what x is. However, I don't need to go back to the table where I can just plug it into the same steps apply, except now I just plug it into the inverse. Is it inverse t? Oh, why is it inverse t? Second. Into the inverse norm, sorry. Into the inverse norm function. Okay, so again, my inverse norm function, it's number 3, and it is the it prompts you to give a probability, which we just figured out. The probability is the x. That's what we've been trying to do. Basically, this is another way of saying that my probability of z is less than 1.32 is 0.9066. Which means that there's a 90.66% chance that my data value has a z-score less than 1.32. So what I'm gonna do is I'm gonna do the probability, which we already said is 0.9066. And then my mu, again, this is a normal distribution. My mu and my sigma are constant. My mu is always 0, and my sigma is always 1. I'm gonna close it, enter. I got 1.32, which is exactly the same. I got it here, 1.32, which is exactly the same as this number right here. I mean, not this number right here. What am I saying? But yeah. So this is it. Now that we figured out our z using the calculator and using the z-score table, you can do the same for most of the problems that are in that set. See ya.